the right button on it, so if you really want to use your phone, you can. Yeah, your phone has the sine, cosine, and tangent buttons on them too. So, yeah, it does. Turn it sideways. What? No. I wanted you to do it during advisory. Alright, so we're going to look at some more trig functions today. Today we're going to use the calculator instead of special right triangles. So you can use a calculator to find missing side lengths of triangles that do not have 30, 45, or 60 degree angles. So example one of this, we're going to use a trigonometry function to find the value of x and round to the nearest tenth if necessary. So we're still using sine, cosine, and tangent. So what you want to do, focus. You want to go from the acute angle you're given, not the 90-degree angle. Okay, so you're going to go from the acute angle you're given, and you want to identify the sides of that right triangle from that angle. So here, from this angle, what would be side 11? Opposite. Okay, what would be x? Hypotenuse. So I have opposite and hypotenuse. Do you remember which trig function that is? Sine. Okay, so I'm going to take sine of the angle I went from, which is 24. Okay, that's equal to your ratio of O over H. So 11 over x. Okay, and we want to solve for x. So we're going to multiply by x on both sides. So I have x times the sine of 24 equals 11. Divide by sine of 24 on both sides. Okay, so I have x equals 11 over the sine of 24. And we're going to plug that into our calculator. Alright, this is a review, and we're going to do something new after this one. Relax.
Next. Exciting.
Alright, so here we're going to plug in 11 divided by, you're going to press the sine button, okay, of 24, and my parenthesis, then press equals. Okay, you should get 27.0 since I'm rounding to the 10th. Okay, so it wanted me to round to the 10th, so I just rounded to that 10th. That's why I have that 0.0 there. Okay, if you were using your phone, you're going to have to enter it differently. You won't get 27 if you do it that way. Okay, so if you're using your phone or a different type of calculator, see if I have one here. I think this one does that. Yeah. Okay, so if you use a different type of calculator or your phone to answer these problems, you're still going to type in 11 first, then divided by, then you need to type in your angle measure. Okay, so that would be 24, and you want to press sine, okay, and get a decimal, then you have to press equals. Okay, so you still have 11 divided by, but then you need the angle, sine, then equals. All right, so moving on here. Moving on. So when solving equations like 3x equals negative 27, you use the inverse of multiplication to find x. So you would divide by 3, right? That's the inverse of multiplication. So you can also find angle measures by using the inverse of sine, cosine, or tangent. Okay? And again, this is to solve for the angle. So this is when your variable, so in this case, A is part of the angle. So you would bring in sine inverse to both sides. When you do that, it cancels on that left-hand side, so you get A is equal to the sine inverse of 0.5. Okay, so angle A would be 30 degrees if you were to type that into your calculator. So we're going to go through some examples of doing this inverse. So again, we use the inverse when we're solving for an angle. Okay, so I'm going to write that. Use inverse to solve for an angle. That's the only time you use that inverse button. Okay, you don't use it when you're trying to find a side of the right triangle, just the angle. So in number 2, the angle we're trying to find is this one right here. So that means I'm going to go from that angle and identify my sides. Okay, so with that angle, this side would be what?
90.
Adjacent.
Oh, the other one's 90.
That angle's 90, yes. Okay, and then this side would be?
Hypotenuse.
Yes. Okay, so I have adjacent and hypotenuse. Which trig function is that?
Hold on.
Cosine. Okay, so we have cosine of the angle we went from. In this case, it's the variable x. That's equal to your ratio of sides, and cosine is adjacent over hypotenuse. So we have 15 over 17. Now, since my variable is the angle, I'm going to bring in inverse cosine to both sides. Okay? Because when I do that, they cancel on the left-hand side. So I'm left with x is equal to cosine inverse of 15 over 17. And we can plug that into our calculator. Okay, so here, on this type of calculator, you need to press second, okay? And then the cosine button, if you look right above it, you can see that cosine inverse. That's why we're pressing that second button. Is that my second button didn't work? There we go.
28.07.
And then we need to type in our fraction. Yes. So you get 28.07. But we're rounding to the 10th, so 0.1. Okay, so 28.1 degrees. Now, if you have a different type of calculator, I think you can still do cosine inverse on your phone. You need to first type in the fraction. So 15 divided by 17, press equals and get a decimal. Okay, then you need to press your second, or if it's already cosine inverse button. So first you want to get the decimal for that fraction and then press cosine inverse. All right, questions on that example right there? All right, do number 3.
Easy clap.
Do number 3. I'm going nowhere.
6.3.
You just go. Yes. To go to Arizona, and then I have to go to Missouri, and then I'm in a wedding next January, so lots of weddings. All right, so going through number 3, we're going to go from x. Okay, we have the side opposite x and adjacent. Okay, so since I have opposite and adjacent, that's tangent. So we have tangent of our x value is equal to the opposite side, 27, over the adjacent side, 18. Since I'm trying to solve for that angle measure, you need to bring in tangent inverse to both sides. So you end up with x is equal to tangent inverse of 27 over 18. Okay, after you plug that into your calculator, you should get x is 56.3 degrees, rounding to that tenth. Okay, so make sure you can enter it in your calculator correctly. All right, we have one more part here. So on the back, it's the same as what we've been doing, except now you're just given a problem. You have to create your right triangle to solve for that side. Okay, so in the figure at the right, the angle formed by the line of sight from the swimmer and a line parallel to the horizontal is called the angle of elevation. So the swimmer is right here. Okay, the line horizontal is the line horizontal to the swimmer. Okay, that's that horizontal. Now if he is looking up,
attention juniors, please report to the auditorium at this time. Make sure to bring your Chromebook and note card with you. Again, attention juniors, please report to the auditorium at this time. Please make sure to bring your Chromebook and note card with you. Thank you.
all right, so if the swimmer is looking up at the lifeguard, this angle, quiet please. This angle formed by the horizontal and that line of sight is called the angle of elevation. Okay, the angle formed by the line of sight from the lifeguard, okay, line of sight is right here. Okay, that's that horizontal. Guys. And the line parallel to the horizontal is called the angle of depression. So if the lifeguard is looking down at the swimmer, between that horizontal line, so your line of sight coming straight off of your eyes there, and then looking down, that creates this angle right here, and that's called the angle of depression. Now, since your horizontal lines are always parallel to each other, that means your angle of elevation will be equal to your angle of depression. Okay, so those angles are always going to be the same measure. So we're going to go through 2 examples here. So number 4, a ramp for unloading a moving truck has an angle of elevation of 32 degrees. Okay, angle of elevation of 32 degrees. If the top of the ramp is 4 feet above the ground, estimate the length of the ramp. So I have the moving truck right here. Okay, the top of that ramp is 4 feet off the ground. Okay, and the angle of elevation of the ramp would be from the horizontal, which is the ground, up to the moving truck. Okay, so that would be this angle right here, and that is 32 degrees. Okay, and we want to find the length of the ramp. Okay, the length of the ramp would be this length right here. So I'm going to label that with a variable. Now, we're going to do the same thing we were doing on the front. This is a right triangle. and I want to use sine, cosine, and tangent to solve for x. So if this triangle is too small, you can quickly redraw it just off to the side here if you need to. So we have 32, x, 4, and this is 90. Okay, so I need to go from that angle of 32 degrees, since that's the acute angle that I was given. Okay, and I want to identify the sides that I'm given in this triangle. The side of 4 would be considered what side? Opposite. And then x would be considered hypotenuse. Okay, so we have opposite and hypotenuse. That is sine. So we'll use sine from the angle. Okay, the angle that we went from is 32. That's equal to our opposite side is 4 over our hypotenuse is x. Okay, what's my next step? Multiply by x. So I have x times the sine of 32 equals 4. Now what do I do, Eric? Divide it. Okay, so I can plug in 4 divided by sine of 32 into the calculator. And I got 7.5 feet. Okay, so you just have to use what your given information is, draw that right triangle out. Since we are working with sine, cosine, and tangent, it will always form that right triangle. Okay, so you should always have that right triangle somewhere in your drawing. Questions on number 4? All right, then number 5, this time I'm not given a picture, so I'm going to have to draw it. So the hill of a roller coaster has an angle of descent, so an angle of depression of 60 degrees. Its vertical drop, vertical, is 195 feet. We want to estimate the length of the hill. Okay, so if you have the hill of a roller coaster, right? Since it's talking about the angle of depression, that means you're going to need a horizontal from the top of the hill. Okay, so here's the top of this hill for our roller coaster. It has a horizontal line. That angle between your horizontal and the hill itself is your angle of depression. Okay, it's not between your vertical and the hill. Okay, that's where most people usually get mixed up. Okay, so this angle right here is 60. Now it has a vertical drop of 195. So that means I can draw a vertical line, okay, from the top of the hill down to the bottom. That would be its vertical drop, and that's 195. So you could draw the vertical drop over here, but it's going to be the same length because they're parallel to each other. Okay, so that's why I drew mine on this side. Okay, that forms your 90-degree angle. Which side are we looking for? The hypotenuse, because we're looking for the length of the hill. Okay, so I'm going to go from this angle of 60 degrees, since that's my acute angle. I have an opposite side and a hypotenuse, so I will use sine. Good. I'll use sine of 60. Okay, that's equal to the opposite side over the hypotenuse. Multiply both sides by x. So we have x times the sine of 60 equals 195. To get x by itself, divide both sides by sine of 60. So I end up with x is equal to 195 over sine 60. You can plug that into your calculator. I got 225.17 feet. What? Feet? Okay, questions on how I drew the picture, where I labeled anything, why you sign, anything like that?